I'm starting recording. Okay, so we are recording. So before we start with the class, I wonder if you have any question on the homework that you just solved. So if you have question, please let me know. No, you don't have question? So it's important to ask me question now, because we are going to have the first exam on the first quiz next week. So if you have any question, I would like to know them. Any exercise that you could not do. So that was homework number 1. I'm going to go over all the questions. And if there is one that you have problem with, please let me know. So this is question 1. I'm going to scroll down. Just stop me in case that you have one that you could not solve. Yeah.
Did you say it was going to be an exam or a quiz next week?
Yeah, I'm going to talk about that again. No question on all this? Oh. Okay, question number 23. A subnet administrator have a block of IP address, which is 10.5.4.0/23. For this block of IP address, he created 32 subnet of the same size with a prefix of /28. So if I go from /23 to /28, I borrow 5 bits. 2 to the 5 is 32. So yes, I do create 32 subnet, okay? He wanted to determine the directed broadcast address of each subnet. He wrote down a list of possible broadcast addresses. Select the IP addresses that do not correspond to a broadcast address for any subnet he created. Choose 2 options. Okay, so let me open Paint so we can solve that. No? It was? Okay. So a /28 is what in the dotted decimal notation? So 4/28 is 255, 255, 255, and the last byte will be what? 224 will be a /27. 240. So the magic number is what? 256 minus 240, which is 16. And the magic number is in the 4th byte. So we are going to go by step of 16 in the 4th byte, okay? So what are the possible network? So subnet. So the first one will be this one, no? Then since we go by step of 16, we will have also 10, 5, 4, 16, /28. We will have 16 plus 16 is 32. We'll have 48. We'll have plus 16 will be 64. Plus 16 will be what? 80, no? Okay, let me continue here to write them all. So we will have also 10, 5, 4, 96. /96 plus 16 will be 112, no? 122, sorry, or 112. 112, no? Yeah, 112. 112 plus 16 will be 128. 128 plus 16 will be 144, no? 144 plus 16 will be 160. 176. We still have more network. So let me write 10, 5, 4. 176 plus 16 will be what? 192, correct. 192 plus 16 will be 228, 208, yeah. 208 plus 16 will be 224, isn't it? 224 plus 16 will be 240. And 240 plus 16 will be 256. So it's not a network, no? It's already out. If you count them, we need to have 32 subnetworks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? 16 subnetwork. 32 /28. Oh no, we still have much more. Oh, we have the 256. I'm sorry. We have the 256, but this time it's 1055. Okay? Oh, 10550, not 256. After 1054, we have 1054. Then we have 10550. So we still have more, no? 10, 5, 5, 16. And they will go up to 1055, 240. Do you agree? And will give us 32 subnet. So they ask us which one of these IP address are broadcast address. So let's see. 105495. So 95 is just before 96. So of course 95 is a broadcast address. It's the broadcast address of this one, of the 10.5.4.80. Do you see it? So this is correct. This is a broadcast address of one of the subnetwork. Then we have 10.5.159. So 159 is just before 160. So yes, it will be a broadcast address, 10.5.159. So it's a broadcast address, no? Because we are looking for broadcast address. So the other should not work. 10.5.207. So where is 207? 207 is before 208, so it's also a broadcast. Genetic broadcast address of each subnet. Here I wrote down a list of possible broadcast address. Select the IP address that do not correspond. I was doing the one that do correspond. So this also corresponds to a broadcast address, no? As we say, before 207 is before 208, and here we have 208. So it's a broadcast address. Then we have 10.54.47. 47 is just before 48, so it's also a broadcast address. So the two one that we are looking is the last two one. So let me invert them and show that the last two one are not broadcast address. So 10.557, of course, 10.557 belongs to this network, and it's a valid IP address. Belong to the first network, the 10.540, and 10.5.478. 78 belong to this network, the 64. So in this network, 64 is the network address, and 79 is the broadcast address. So of course, it's not 78. 78 is the last valid. So these two are valid IP addresses. Okay?
Can you go back and talk about number 24, I think it was? Yeah.
Which of the following network identifier are valid? Select two options. So what is the property of the network identifier or of the network address? If you bitwise AND with the mask, if I take an IP address, let's say that I take this IP address, 12.7.8.200/25. How can I know to which network this IP address belongs? You can do, for example, 10.7.8.200 bitwise AND the net mask. Okay, so the net mask is 255, 255 here, 255 here, 128. So when you make 12 bitwise AND 255, it will give you 12. 7 bitwise AND 255, it will give you 7. 8 bitwise AND 255, it will give you 8. You just need the last one. So if you look the last one, you can put it in binary to realize. So 200 is 128 plus 64 plus 8. So 200 is 128 is there, 64 is there, 32 is not there, 16 is not there, 8 is there, 4 is not there, 2 is not there, 1 is not there. This is 200. And if you bitwise AND with 128, what is the result? 128, isn't it? So this IP address belongs to this network, to the 12.7.8.128. So if this identify a network, what can I say? If I bitwise on 172.16.3.160 with the net mask, which is /27, so /27 give me this, another 255, and here a 192. If I, no, 224, sorry. If I bitwise on this, I will get what? 172, then 16, then 3. The only complicated is the last one. So 160 is 128 plus 32. And that's it, isn't it? So it's 128, 64, 32, 16, 8, 4, 2, 1. bitwise on 224 is 1110000. What is the result? So I will have a 1 here, a 0, a 1, 0, 0, 0, 0, 0. So it's 128 plus 32. It's 160. Which means that, what does it mean? That this is a network address because it's the same one. So this IP address belongs to this network. Since it's the same one, this is a correct network identifier. So this one is a solution. You understand why? So you just bitwise on this with the net mask, and if it gives you the same IP address, it means it's a network address. If it's a network address, it's identify a network. It's not an IP address that I assign to a computer. Okay?
Could you do number 32 as well?
A network administrator has divided a network in 32 subnets of equal size. So we went from a /16 to a /16 plus 5, isn't it? 16 plus 5 is 21. So the subnetwork are /21. What is the common subnet mask? That will be the common subnet mask, which is a 255, 255. So here I'm missing 5. It will be 248, no? 0. This is a common subnet mask. Do you agree? So what is the total number of IP addresses in each subnet? So it will be 2 to the 32 minus 21. So 2 to the 11. So I have 2048 IP addresses in each subnetwork, isn't it? Okay, then complete the following table. So let's do this one, subnet 12. So remember, what is the magic number here? 256 minus 248. It's give me what? 8. 8 in the third byte. So I go by step of 8 in the third byte. So if I want subnet 12, it will be what? 172.16. So here, since I want subnet 12, it will be 12 times 8. Isn't it the byte that go here? I have to compute it. .0 /21. So it will be 172.16. So 2 times 8 is 16. So there is a 6. And I have a carry. 1 times 8 is 8. 8 plus 1 of carry is 96. And 0 /21. Isn't it? Because remember, in the third byte, you go by step of 8. So in the third byte, for network sub 0, you put a 0 in the third byte. Okay. For network sub 1, you put a 8. For network sub 2, you put a 16, which is 2 times 16. For network sub 3, I'm talking about the third byte, no? You put a 24. So the one that is going to vary is here. And of course, for network sub 12, 12 times 8. Okay, be careful, network sub 0 is the first subnetwork. We start counting in 0. So when we say the first subnetwork, we are talking about network sub 0. Okay? Okay. So today, okay, let me clarify that. We have quiz next week. So the quiz will be on Tuesday. I will send an email after class about it. And we have exam on Thursday next week. So all the material that we have seen so far will enter in the exam. Okay, so be sure you do all the question of subnetting of IP addresses before the quiz. So you should be good for the quiz. Okay, so I will send an email about that, but you already know that we have quiz next week. Okay, today I'm going to talk about a company that is called Cisco System, which is a very influential company in the world of networking. And we are going to see how we can configure their devices. Okay, so in a device, in a computer, a networking device in general, you have several layers. So the first layer is the hardware. On top of the hardware, you install an operating system. In this operating system, you have application like a shell. So if I take the case of the PC where I'm just in front of it, it have a microprocessor, which is a i3, I think so, i5, we can check it if you want. So Intel. So I can install several operating systems. I can install, for example, Windows 10. This is the case here. But I can install Debian if I want. Or I can install other operating systems. If you take your cell phone also have an operating system. It might be Android, or it might be the operating system of Mac, no, of Apple, the iOS, no. So you have an operating system. And if you take, for example, at home, you have a wireless access point or a wireless router. It's also have an operating system. So we have an operating system on top of the hardware. And the operating system is there to manage the resources of the device where the operating system is running. No? And at a higher level, you have, of course, applications, or you have programming languages, tools that will allow you to take advantage of your operating system or of your device. When we will talk about switch and router, they also have an operating system. And the operating system of Cisco is called iOS, Internetwork Operating System. So it depends if we have a switch or a router, we will use an iOS that is adequate for the model of the switch of the router. So iOS stands for Internetwork Operating System. So Cisco is a very important company in the world of networking, and they got the importance because a few years ago, they started some academy worldwide to teach people computer networking. So they have several certifications. The entry-level certification is called CCNA, Cisco Certified Network Associate. It's a basic certification. It's done in 4 semesters. So you have 4 courses that you have to take before you can present the certification. A lot of people have the CCNA because it's low level. On top of the CCNA, Cisco have something that is called the CCNP, Cisco Certified Network Professional. It's a much difficult certification. Very few people in the world have it, to tell you the truth. And there is even a higher certification from Cisco, which is called CCIE, So this is very, very few people in the world that have CCIE. And of course, if one day you are lucky and you get a CCIE, you will get a job anywhere in the world and you will be very well paid, no? Because you show mastering a very high level of mastering the technology of Cisco system, which represent more or less, I would say, like 80% of the market. Cisco system is very famous. Many people buy the switch and router of Cisco system. For example, the university is one of the buyer of Cisco system. When we install switches and router here in the university, we buy Cisco system, no? So those are router of Cisco system. They are pretty old. The family is 2500, so they are 2501, 2503. So those, as you can see, it's look like a black box. This is the front part, and you install this router in a rack. So we have different kind of rack. Unfortunately, here there is no rack to show you. As you can see on the side of the router, we put support. We call that ears. And through this support, you install your router in the rack. So the router have no keyboard, no mouse, no screen. And those equipment, you put them in the wiring closet. You configure them, and they will be working for years in the wiring closet. And normally, if you don't have a misconfiguration or you don't have any change in your network, you don't have to change your configuration for years. They just run there for years. So it's not a place, it's not a device where you are going to run application, user application. They will just do routing, or they will just do switching if they are switch. So this is the front part of the router. This is the back part of the router. So this router is not modular. When I say it's not modular, it means that there is no slot, additional slot that are empty that you can open and add additional card, additional networking cards. So the way that you buy them is the way that you are going to use them. The only thing that you could modify in this kind of router is the amount of RAM or the amount of flash memory. So you could open them and change the amount of RAM or flash memory, but otherwise they are not modular. So here, as you can see, we have the socket to connect the energy. Here we have a power button, on and off, and we have some connectors. So this is the auxiliary port. The auxiliary port is not used anymore. At the time of the plain old telephone system, it's still there, but it is disappearing. At the time of the plain old telephone system, what we will do, we will have a modem, and we will connect this router to a modem. So the network administrator, when he will have to configure the router, it will dial into the router and change the configuration. So it don't have to go in the wiring closets. You want to avoid to go to the wiring closet because it's not a place where you will feel comfortable. Most of the time, they are far away from the network administrator because the company might have branches in several cities. And due to that, there are maybe 1 or 2 network administrators, and they have branches in 10 cities. They cannot send the network administrator every time that you have to change something in the router. They cannot change it. They cannot send it to the place, because this will mean that I have to pay an airplane ticket. I have to pay the hotel, because maybe the network administrator is in Miami, and you have to intervene. We have a branch here of the company, small branch. We do have a router because we have a branch. I'm not going to send the network administrator from Miami to here every time that there is a problem here. So what I do, I connect the router through a modem, and the network administrator that is in Miami just dial into the modem, dial into the router, and make the configuration that he want to do. So the plain old telephone system is disappearing, still there, but you listen very little about it. So this is not a solution anymore. Here we have a console port, sorry. So this is much more common. And we are going to use a cable, which we call the blue cable. I have one here. I'm going to show you a slide after with a blue cable. So this blue cable is called a console cable, no? So on one side, we have a RJ45, which is the one that I will put in the router. On the other side, I have a DB9, which is RS232, which is a serial connector. So in the past, the computer used to have serial connector. Now the computers are so small that we don't use this connector anymore. But at this time, I will connect that on the console cable that I'm showing there in the screen. On this side, on the computer. And I will use a terminal emulator, and I will be able to configure my network device. Today, the computer don't have DB9 anymore. They don't have serial port anymore. So what they came up is a converter between serial to USB, because we have USB. So if you look here, I have a DB9, which is a female connector, and in this converter, I have a DB9, which is a male connector. So I'm going to connect them together, and as you can see now, I have a USB at the end of my blue cable, or my console cable. So this is what we are going to use. This side will go to the computer, and this side will go to the, I have a switch today, we'll go to the switch. Then if you look here, we have another connector. I'm not sure, I think it's an Ethernet connector, which is a standard connector. And we have two serial connectors, and we have another Ethernet connector that use the AUI connector, which is the old version of Ethernet. Ethernet doesn't use this kind of connector anymore. Ethernet uses this one, which is the RJ45. So this router is obsolete. This router is more recent. The family is 1700. So here we can see a console cable or a blue cable. So you see the DB9 connector here, which is a female connector that you will connect to the computer, on the RJ45 that you will connect to the console. Here is the console port. So this is the front part of the router. This is the back part of the router. So this router is modular. As you can see here in the back, we have this protector. I can unscrew it and insert here a network card. And here we have another slot that is free in this moment, so I can unscrew it and here add a network module. Okay, those modules are called WIC, one interface card. So we have two slots where we can add one interface card module. So here we have the console connector, it's the RJ45 to connect this cable. Here we have the auxiliary port. It is identified by AUX and the black color to connect a modem. Here we have an Ethernet port, the conventional Ethernet port that you have in all those computers around the classroom. This is Ethernet port. And if you look here, they did open this router, and in the right slot here, they put a WIC card. This card is a WIC 2T. As you can see, we have two connectors here. They are smart serial connector. So I can add functionality to my router because my router is modular. It's a small router. It just have 2 slots for you to add additional feature to the basic version of the router. So this router is even more recent. This is the 2800 family of Cisco. So in the front part, we can see here the power button, the auxiliary port, the console port where we are going to connect the blue connector, the blue cable, the flash. So the flash now is outside. So if I want to update my flash memory, I don't have to open the router anymore. I just expose this flash and put a flash memory with a higher size. In previous router, you do need to open the router because the flash is not accessible outside. So this one, the flash is accessible outside. It's a little easier to update the flash memory. And as you can see, they already have USB port. The previous router didn't have USB port. They have USB port. So if you want to update the operating system, you can copy the operating system in a thumb drive. You put the thumb drive here, and you can copy the file of the operating system from the thumb drive to the flash memory. Okay, here. This is where the operating system has to be stored. There is, in this router, there is no hard disk or SSD. So the operating system is stored in the compact flash here. And when I need to create files, I will create files. When the router needs to create files, it will create it in the compact flash. This is the back part of this router. So as you can see, it's modular also. Here we have a gigabit Ethernet port, a second gigabit Ethernet port. So we have 2 gigabit Ethernet port. Here we have 4 slots. First slot, second slot, third slot, fourth slots to add a card that are called WIC, W-I-C, for one interface card. And here we have other slots. They are much bigger, as you can see. And those slots are called NM, for network module. So depending on what you want to give additional functionality to this router, the card that you will buy will go either here in a WIC slot or in a network module slot. So you see, this is the previous router of the second one that we saw, no? Of the 1700 family that have 2 WIC slots. So here they put this card inside. So they unscrew the protector and they inserted this card. So this card is a WIC 1T. It provides one serial connector. It's not a smart connector. It's the old connector that Cisco used to use. But they don't use it anymore, and they use the smart serial. So WIC stands for one interface card. So here we can see the console port, we can see the auxiliary port, and we can see, yeah, I have a question previously, what was this? I can see it now because it's bigger. It's a Ethernet port. So it's a fast Ethernet port. It can work at 10 Mbps, megabit per second, or 100 Mbps, according to what you will connect to this port. So this is the same router of the 1700 family. This is a 1720. And in this case, we replaced the 2 slots with WIC cards. So in the left slot, we put this card, which is a WIC 2T. So it has 2 serial ports. And as you can see, it's different. The serial port here is much more smaller than the previous one. That was the one that Cisco was using at the beginning. Then Cisco make a smaller serial port. So it can accommodate 2 serial ports on a WIC 2T. One interface card 2T, 2 serial port. No? Here we have ISBN card that was added to the router. No? Okay, So a router is like, it's like a computer, but with a specific purpose, which is do routing. A switch is like a computer, but with a very specific purpose, which is do switching. So the difference with a computer is that they have a lot of ports, because you will connect to them a lot of devices. While a computer normally have one port, maybe a server have several ports, or if you use a computer as a router, you do have to have several ports, no? Or as a switch, you do have to have several ports. So it's a computer with a specific purpose. Since we don't run a user application on a router, we don't need a keyboard, a mouse, on a screen, okay? Because nobody's going to sit in front of it, and it's going to be in a wine closet. So we have in the router of Cisco, we have different kind of memory. So the first one that we have is the RAM memory, random access memory. So this is a volatile memory, which means that when you power off the device, the information that is stored in this memory will be lost. So this memory is very fast. Is the faster, okay, the cache memory will be faster than that, but it's one of the faster memory that we have in the device. So when you boot a router or a computer also, it will load the operating system in RAM. So in the RAM, we'll have a copy of the running operating system. In the case of the Cisco router, we will have a file that is called the running config, which is the actual configuration that will be stored in the RAM memory. All the structure that the router need or the switch need to run will be stored in RAM memory. For example, the routing table of a router is there. The ARP cache is there. Okay, so they will store a lot of information in RAM. So we have another kind of memory, which is called ROM, read-only memory. So this memory is burned by the manufacturer, and you cannot change it. So the manufacturer is going to put a very basic operating system in the ROM memory. So when you start a router or a switch, it will first go to the ROM memory where it has a very basic operating system. And with this basic operating system, it will check some of the hardware to see that they are working properly. And it will have information on how to load the full operating system, which will not be stored in ROM, of course, no? Because what you store in ROM, you cannot change it. And you want to update your operating system because there is always bug in the operating system. So the manufacturer will always tell you, hey, there is a thread or there is there are critical issue in the last version of the operating system. You have to upgrade to the new version. So of course it has to be stored in some media that I can erase and put again new information. So it's not the ROM. We have the flash memory. So when I was showing you the last router, let me go back. Here, this is the flash memory. It's a compact flash. This is where we are going to store, for example, the operating system. So in the past, the flash memory used to be very expensive. We will have flash memory with very small capacity. For example, like 64 megabytes, maybe 128 megabytes. So the flash memory was so expensive some years ago that the operating system will be compressed first before the people will copy it on the flash memory. Today, the flash memory is very cheap. No, you have pen drive. Pen drive is based on flash memory, and you have capacity of gigabyte. No, I'm sure that your pen drive is at least 8 gigabytes. So today we don't have this issue, and an 8 gigabyte pen drive will cost like maybe $10 a good one. So of course, it's not required to compress the operating system anymore, but it used to be in the flash memory, no? So when you boot a router or a switch, it will go in the flash memory where it will find the operating system, and it will load the operating system from the flash memory to the RAM. There is a fourth type of memory, which is called non-volatile RAM. And in the non-volatile RAM, as its name say, it's a RAM memory, which means that it's very fast, but when you power it off, it will not lose the information. It will keep the information. So in the non-volatile RAM, Cisco store what we call the initial configuration of the router. And it's this initial configuration is called startup config. So the actual configuration is called running config, and the initial configuration is called startup config. So when a Cisco device starts, it will do a power on self-test, which means it will test its hardware. Then it will load the operating system from the flash memory to the RAM memory. Then it will go in the NVRAM and check the startup config file, where it will find the initial instruction to configure itself. And it will load the startup config into RAM. And when it is loaded into RAM, it is called the running config. Okay, when you configure a Cisco router, you have different ways to do it. So one possibility, you use a GUI. So of course, people that are not expert, which means not you, like GUI because they click and they are very happy with clicking. You as a computer scientist don't like GUI. What you like is the command line interface. You like to type command because with command you can do script. So it's much more powerful to use command than to use a graphical user interface. So we will not use a graphical user interface. This will be for somebody that don't have experience at all that will use that. So another way to configure a router is through the CLI, the command line interface. And this is the one that we are going to use to configure the router and the switch that we are going to have in the labs. So it's text-based. It's a little less friendly, but it's very powerful. And you can create script, which is a sequence of commands that you want to execute at some point. You cannot do that with the graphical user interface. Now, the graphical user interface is user-friendly, but it's very limited. So there are many versions of the Internet Network Operating System. For example, Cisco has version for switches, version for router, version for access point, because Cisco also sell access points. And if you take a specific router, let's say that you have a 2801 router, Cisco have several iOS or several operating systems for this router. Because of course, it's first of all, historically, when they do a device, they do a first operating system, then they update it. So they create versions where they fix the bugs, where they add functionality. So of course you have at the end a lot of versions, and some version support some feature, other version support other features. So for example, we have a lot of encryption algorithms. Many of them were designed in the US. So there are some law in the US that say, for example, this encryption algorithm cannot be exported in this country. So if you are going to sell, if Cisco is going to sell a router in the country where the American law does not allow to use this encryption algorithm, they have to sell it with an iOS that doesn't have this encryption algorithm, because they are going to sell it to a country where it's forbidden to send iOS with this encryption algorithm. Inside the US, there is no limitation, but outside the US, some countries that are, let's say, considering not very friendly to the US, the company cannot sell all the things that they want to sell them, okay, because they are not very friendly to the US. So of course we want to avoid any conflict with those countries. So we don't sell the last technology that we have to those countries to avoid that this country use this against the US at one point, no? So you go to the webpage of Cisco if you have a CCO account, and you can download. As you can see in these slides, for example, I have several versions of the iOS. That will be for 2960 router. It's a switch, sorry, 2960 switch. So you have a different version. For example, the LAN base, the LAN light, and you can have a different also version. So for example, this is version 15.2.3. This is previous version 15.02. Okay, so of course there are a lot of versions. So according to the version, they will ask you to have a certain amount of RAM and flash. So of course, if you don't have enough RAM, you cannot maybe use some version that require more RAM. So the version that you are going to put in your switch or your router will depend also of the amount of RAM that you have and the amount of flash that you have, no? Okay, so as I was saying, there are different ways to configure a router today. So the console port with the blue cable is the most common. Okay, you use this blue cable, you connect it to the network device, and the other end of the blue cable go to your PC or your laptop, and you configure it with a console port. Another way is through a network protocol, but you can use Secure Shell only when you already partially configure your router. So for example, you already put an IP address into the router, so you can Secure Shell in it. And there is a third way, which is another network protocol, which is called Telnet. So Telnet is a network protocol that was done in the 1970 when TCP/IP was recently released by the Department of Defense. So it's a very old protocol. At this time, security was not an issue. And this protocol will transmit the logging and the password of the user in clear text. So it's not a good idea, because if there is somebody that is sniffing the network, somebody that is capturing the traffic, this person will have the logging and the password. So today you should not use Telnet anymore. And after some years, they came up with this protocol, Secure Shell. It's a similar protocol, but this one encrypts. So it will allow you to do a remote session. So you don't have to go to the wiring closet to access the network device that you want to configure. And your communication will be encrypted, which means that it should be safe from people that want to do damage to your company, no? Because they should not be able to understand the conversation between the network device that you are configuring and your laptop or your computer in your office. So the auxiliary port is old and is not used anymore. So if you are going to use the blue cable, this is the one that I'm going to use to configure the router, the switch that I have, I need a terminal emulator. In the terminal emulator, we have several terminal emulators. I'm going to use this one, TerraPro, but you can use PuTTY. Both of them are free. When you configure them, you have to specify, for example, here you will have to say, I'm going to use the serial connection. Here we will have to say, I want to use a serial connection here, because this is a serial connection. The parameter that you have to set up in the serial connection are the following: 9600 baudios, no parity byte, 8 bit of data, 1 bit of stop, and no bit of control. So in the software, we will be allowed to do that. So the iOS, which is the Internet Network Operating System, is very rich in command. They have a lot of command. So most of the system administrator just know a very small percent of all these commands because it's a very complex operating system at the end. So it has several modes. For example, there is a mode that is called the user mode, the privilege mode, the global configuration mode, the interface configuration mode. And according to the mode where you are, you will be allowed to type some command or other command. So when I'm in the user mode, the prompt of the switch of the router will look like that. So if it's a switch, it will tell the name of the switch and it will have a greater than. So when I see the prompt like that, I know that I'm in the user mode. If it's a router, it will say router and it will have a greater than. So in the user configuration mode, you cannot change anything in the router. You can just show, or you can just view, or you can just get information. You cannot set. You can get information, but you cannot change them. So command that will be able to use in the user mode, that we also call the view only mode, because you cannot change anything, are those commands. For example, ping, to ping a remote device, trace route, to see the route from my device to a remote device, secure shell, telnet, show IP route, that will show you the routing table, show IP protocol, that will show you the routing protocol, the dynamic routing protocol that are running in a router, for example. Show version will show you information of the hardware and the software that are running in the network device. Show history will show you the history of all the commands that you have typed. Not all the commands, but the previous 40, for example, okay? So all those commands that are here are available in the user mode. So there is another mode that is called the privilege mode. When I'm in the privilege mode, the prompt will look like that. So we'll have the name of the switch or the router and a sharp at the end. When I see that, I know that I am in the privilege mode. So in the privilege mode, you will have some administrative privilege, some management privilege. So for example, you will be able to deal with the running config and the startup config that I was commenting previously. So remember, the running config is the actual configuration. The startup config is the initial configuration. This one is in RAM. This one is in NVRAM, no? So you will be able also, for example, to manage the file system. So for example, you will be able to rename file, copy file, delete file, show the content of a directory, show the content of a file with the more command, create directory, remove directory, change directory. You will be able, for example, also to debug your router or your switch. You will be able to change the hour and the date that is stored in your router. No, for example, if there is any change, it's not the correct hour, with the clock sec command, you can change them. So that gives you some administrative privilege already when you are in the privilege mode. So other mode are the global configuration mode. In the global configuration mode, what you will change is things that will affect the whole router. For example, you can change the name of the router. You can change the routing table of the router. If you work with frame relay, you can add map, which is how a DLC is associated with an IP address. So you can do that, which are global commands. Now, since the device is going to have several interfaces, you can change the configuration of each interface. So this router, this is a switch, sorry. This switch have 8 ports. So I can change the configuration of each port. So for that, I will have to go to the interface configuration mode of the interface that I want to change, and all the commands that I will type when I'm in this configuration mode will affect the interface that I did specify when I change from the global configuration mode to the interface configuration mode. There are other configuration modes. For example, the line configuration mode will allow us to configure, for example, telnet and secure shell. We will see them today, some example. So there are many commands in the global configuration mode. Here you have a list of commands. For example, you can change the name of the router. You can change the domain name. For example, the domain name here is jsu.edu. You can change it with this command IP domain name. If you have a DNS server that you are using, you can specify the DNS server with IP name server and specify the IP address of the name server that you want. So you have a lot of commands here, as you can see. In the interface configuration mode, you can change the IP address on the mask of an interface. You can shut down the interface. You can enable the interface. You can force a specific speed. So if it's a gigabit interface, gigabit Ethernet interface, you can specify the speed to 10 Mbps, 100 Mbps, or 1000 Mbps. So you have command to do that, no? In the line configuration mode, what we will do is, for example, configure telnet, configure secure shell, specify which input or output protocol I will allow for the router. It's important which input protocol because we should disable, for example, telnet. Okay, there are ways to move around the different configuration mode, and I'm going to skip these 2 slides because there is a summary here, which is graphic and it's much better. So we have the different configuration modes. So this is the user configuration mode. I know it is the user configuration mode because here I have the name of the router and a greater than. This is the privilege mode. I know that I'm in the privilege mode because the prompt is the name of the router and the sharp. This is the global configuration mode. I know that it's a global configuration mode because of the prompt. It will be the name of the router, parentheses config, parentheses sharp. This is the interface configuration mode. So when the prompt is like that, I am in the interface configuration mode. So this is the line configuration mode. How do I change from one configuration mode, from one mode to the other mode? So for example, from the user mode to the privilege mode, there is a command that is called enable. If you want to go back, you are now in privilege mode, you want to go back to user mode, the command is disable. When you are in the privilege mode and you want to go to the global configuration mode, the command that you need to type is configure terminal. If you are in the global configuration mode and you want to come back to the privilege mode, you can use exit, or you can use end, or you can use Control Z. So end and Control Z will bring me back to the privilege mode in general. So if you are in the global configuration mode and you want to go to the interface configuration mode, the command that you have to type is interface, the type of the interface, and the number of the interface. So type of interface can be serial, Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. Okay, it will depend of what kind of interface you are dealing with. With the exit, when I am in the interface configuration mode, I will go back to the global configuration mode. With exit again, I will go back to the privilege mode. If I am here in the interface configuration mode and I want to go back to the privilege mode, I can use AND or Control Z instead of doing 2-time exit. The first time exit take me here, and the second time exit take me back here. So there is a shortcut which is AND or Control Z. Okay, so when we look at the CLI, we will have the prompt, you will type a command, and you will have parameters. Those parameters can be keywords or they can be value. Value, for example, an IP address will be a value, or the name of a device will be a value, or the name of an access list will be a value. It's not a keyword. For example, show IP protocol, IP is a keyword, protocol is a keyword. Okay, in this case. There are some shortcuts to make life easier. And there are two magic keys. So the magic key are the tab key and the interrogation key. I will show you when we connect to the router, the switch that I bring here, I will show you how we use the magic key. But when I want to type a command, like configure terminal, there are some shortcuts. I can just type, for example, conf t. So the router will accept shortcut as long as there is no confusion. If there is confusion, the router will tell you there were a confusion and will ask you to put more character. And don't put the thing as short as you try. So you will put more character and the network device will be able to understand what command you want. There are some keys that you can use in the command line interface, like Control A. It will take you at the beginning of the line. Control E will take you at the end of the line. Okay, so instead of, let me show you some example. Let's say that I just bought a switch and I want to configure it. So at the beginning, I will be in the user mode. So to go to the privilege mode, I have to type enable and look at the prompt change. And it tell me I am in the privilege mode. To go to the global configuration mode, I have to type configure terminal and the prompt indicates that I'm in the global configuration mode. And here, for example, I change the name of the switch and I call it switch floor 1 because it's the switch that is in the first floor. So then the prompt reflects that I changed the name of the switch. By default, the name of a switch is switch and the name of a router is router, but you can change it with the hostname command. Okay. We are going to see all those commands. They are in the slides, so you can come back to the slides. I just want to, because we are already running short of time, I just want to show you a little more about the switch that I just bring today. So it's a small switch. It is there, as you can see. It's in the family 2900. It's a 2960. So this is the console port, the blue port. Those are Ethernet port. I have 8, 1, 2, 3, 4, 5, 6, 7, 8. So I can, for example, here, through a UTP cable, I can connect computers. And those two ports are gigabit port. So if I connect this switch to the backbone, I should use those ports because they are much faster. And here I should put end devices. So this is the back of the switch. We have just the possibility to connect the power. It doesn't even have a switch, power on, power off. It doesn't have a switch to power it on and power it off. So when I connect it, it will be on until I disconnect it, because normally they are in a rack and they run for years. You keep them there and you barely touch them. So I'm going to configure it. So I need the blue cable, the console cable, and I will take this side of the console cable, which is the RJ45, and I'm going to connect the RJ45 to the console port here. The other one, I'm going to connect it to my computer. So remember that this cable was not there at the beginning, and this is just a converter from serial to USB. So when I'm going to connect it to my Windows 10, Windows 10 is well done. It will install the driver of this converter. Here we have electronic. So as soon as I put it, it will install the driver, and it will identify that I install a new hardware. So before I do it, let me open the device manager in my computer. Okay, I'm not administrative user, but it's not a problem. So here we have, let me see if we can. Okay, we have the serial port. There is one port which is called COM1 in this moment. Okay, let me connect this one and we will see what will happen. So I need to disconnect. Let me be sure what I'm disconnecting here is the tablet. Yeah. Don't want to disconnect the microphone, no? Okay. I'm going to connect my cable. The router is not on, so it's like it is not connected to the switch, is not on. So I'm going to connect it, and it should update the serial port. So let me do it. Okay, as you see, it's just say that we have a converter from serial to USB, and it identify the port as COM3. So now we need to download a terminal emulator. I already downloaded it. I download one that is called TerraTerm. So I have the file here. It is free. It is in the internet. You can go and download it. So let me just go and show you. You can put TerraTerm, and it will take you to the page of TerraTerm. It's an open source terminal emulator. So let's download it again. The current version is 4.106. And I'm going to download the zip version. Okay, it is already downloaded. It is there in my download desktop, my download folder. So I'm going to put it here. That was the previous version. And it's a zip file, so I just need to unzip it. Here it is. Let me put in the folder RX so people don't erase it for me. So inside I will have an executable. It is there, TerraTerm Pro. I'm going to double click it. I don't have to install it. And here I can specify if I want to use Telnet, Secure Shell, or Serial. I want to use Serial, so I'm going to take Serial. And the communication port is COM3. I'm going to review the information of the serial port. So you remember that I showed you a slide that say you need to put 9600 baudios. This is the case here. 8 bit of data, no bit of parity, 1 bit of stop, or no bit or 0 bit. There is no bit of flow control. It is already done as I need. So I don't like this background because you may not see it well. So let me go to terminal, and no, it's not here. Let me go to window and say that I want another color, right over black. It's easier to see. And maybe I'm going to say also the font so you can see it better. I'm going to use bold 40. Maybe it's enough. Let me see if we use even something bigger. Let's put 16. Okay, so it is ready. I'm going to connect my switch. When I connect my switch, it will go through the process of powering on. So it will go in the ROM memory and find a very small operating system that will allow it to do a power on self-test, a POST. The power on self-test is where the switch is checking that the hardware is working properly. So every device is, when you put it on, check its hardware to see that the hardware is working properly. And to discover also, because you might have added something. So it has to discover if you put something new as a hardware, because many of those devices are modular, no? So it will do a power on self-test, then it will go in the flash memory and find the operating system. So in this case, the operating system in this switch is compressed. So it will uncompress it and load it into memory. After doing that, it will continue to show a lot of message about the hardware and the software, some copyright, and finally, we will be asked if we want to use a wizard to configure the device where they guide us step by step. Of course, we will not do that. All this wizard GUI is for people that don't know. Since you know, you will say, no, I don't want a wizard. I don't want something step by step. I'm going to type the command by myself because I'm a professional in the area. No? So we'll say, no, we don't want the wizard. It will arrive to the prompt where it will say switch greater than, which is the user mode. So I'm going to connect it, and it's going to start its booting. So we should see in a few seconds some message appearing in the screen. Let me see if I find a place to put it. Not easy. Okay, so we have the first message, as you can see. It says initializing the flash, for example. So it's doing the power on self-test. Look at there. It's uncompressed the operating system, which is in flash. It's a binary file, as you can see. The name of the file is C2960.bin. So it's uncompressing it and is loading the operating system in the RAM. So of course, the operating system is going to run in RAM. It's not going to run in flash. Flash is too slow. So we upload it in RAM. So it's still doing the same thing, which is uncompressing the operating system and loading it into memory RAM. Done. So we have some copyright of Cisco system, some information about, for example, the version of the iOS that we are running. It will also check the hardware. So here is checking the hardware. It will give us information about the hardware. Look at power on self-test, POST. So it's still doing that, checking that everything is okay, all the hardware is okay. And it will show me some information about the port that we have. Those are copyright of Cisco system, or those is hardware information. For example, it say we have 8 fast Ethernet ports we have 1 gigabit Ethernet port. Here it's give me the amount of flash memory. As you can see, it's a very little flash memory. What else can I see here? Okay, so those are the name of the port. Fast Ethernet 01, Fast Ethernet 02, Fast Ethernet 03, up to Fast Ethernet 08. So Fast Ethernet 01 will be this one. The first one that is on the left side of the router. Then Fast Ethernet 02 up to Fast Ethernet 08. This is this one, no, that I'm showing here on the switch, no? Let's see. Okay, so here it asks me, do you want to go to the basic wizard where I will guide you to do the configuration? And of course, we are going to say no. And look at, we arrive to the user mode. So I'm going to type some command like enable. Enable will bring me to the privilege mode. So look at the prompt. When I'm in the privilege mode, it says the name of the router, sharp. So I know that I'm in the privilege mode because the prompt tells me that I'm in the privilege mode. With disable, I can go back to the user mode. I'm in the user mode again. So enable privilege mode. Configure terminal. Here I am in the global configuration mode. If I want to change information of a specific interface, I can do that, for example. Interface 1 out of 0 out of 0, 3. 0, 0 is 0, 1 to 0, 8. So here I am, look at the prompt. It says I am in the interface configuration mode. So I can exit. I will go back to the global configuration mode. I can exit. I will go back to the privilege mode. So let's say that we want to change the name of the router, the switch, because we have a lot of switch. So to do that, you have to be in the global configuration mode and use the command host name. Let's call it S1. Look at the prompt. The prompt says you are in a device that is called S1 and you are in the global configuration mode. So if I exit, I will go back to the privilege mode. So the privilege mode, the prompt is always the name of the device, followed by a sharp. If I type disable, I will go to the user mode. It will be the name of the device, S1, followed by a greater than. So the name by default is switch. So at the beginning, we have this. But if I don't like the name, I can just go back to the global configuration mode and use the command host name, for example, and put switch. We are in a air all 359, no? For example, I could do that. So I know if there is a switch here with the name, I know, yeah, this is the switch that we have in this room. So it's giving me some information. It can be useful if you put name like that. By the way, switch is misspelled. Okay, so this is the way that I change the name. Let me put S1 as we initially have. Okay, so let me show you what you can do. Let me explain you first the magic keys. We have some magic keys. So I want to type configure terminal. If I try CT, it will not work because there are several commands that start with C. So look at it, say ambiguous command. So to know all the commands that start with C, I can type a C and an interrogation. So you see, if I type C, the router cannot know if I want the command call home, CD, clear, clock, CNS, configure, which is the one that I want, connect, copy, or crypto. So I need to put more character. Let's put a O and try with COT. Do you think it's going to work? No. Why? Because starting with CO, we have configure, we have connect, and we have copy. So the router cannot know if I want configure, if I want connect, or if I want copy. So it will still stay ambiguous. If I put an N, will it be enough? No, because we still have connect and configure. So CON is not enough. Ambiguous command. Now, if I put an F, we just have configure. So I can do configure T for configure terminal, and it did work. So why was able just to put T? Because look at, after configure, you have all this possibility. Configure confirm, configure memory, configure network, configure override network, configure replace, configure revert, configure terminal, configure enter. So if I want configure terminal and I just put a T, will the T conflict, or will the T will open several possibilities? No, because with the T we only have terminal. But if I do configure R, with R we have replace or we have revert. So configure R will not work, but configure T will work. Okay, I can put configure TE if I want, or TER. Everything where there is no ambiguity for the router, it will be okay. So this is one of the magic key. So the other that I want to show you is that if you want, you can use the tab key, and the tab key will autofill the rest. So look, if I try to type configure terminal, and after the C, I press the tab key. Since there are many possibilities, it doesn't show me what are the possibilities. So I put an O, it still does not show me. I'm typing tab here. I put an N, it still does not show me. It still does not complete. I put an F. Now you know that there is only one thing that starts with conf, it's configure. I'm going to tap tab, and look, it feels configure for me. Because there is no doubt this is the only command that starts with conf. Now there is a parameter after configure. So if I tap tab, it doesn't fill it. If I tap T, it will fill it. You see, I tap T and tab. Now remember that here we have, for example, several commands that start with R. If I put R on tab, what will happen? There are two possibilities, replace or revert. They both have an E after the R. So if I type tab, it will put the E, but it will not put more than the E. If I need replace, I can put P on tab, and it will put replace. Okay, so this is the two magic key that we have, the interrogation. I just press interrogation. So look, after configure, you can put a parameter that can be confirm, memory, network, blah, blah, blah. So it presents the result as a table. So this is what you can put after configure, and there is a small comment of what it will do. So for example, configure terminal will take me to the global configuration mode. So if I put T tab, enter, I am in the global configuration mode. So for example, here in the global configuration mode, I don't remember the commands that are available. I can just type interrogation. And look at, when I type interrogation, it shows me a table of two columns. On the left column is the command, on the right column is a comment. So for example, I use the command hostname. There are so many commands that I have to go by screen. And hostname is there. This is a command that we use. And it will specify the the host name of the device. So when I remember the command, I can type it. And for example, here I don't remember the syntax. What's come after host name? I can use interrogation. And it tells me you have to put the name of the device. So let me put, for example, switch all 359. And I don't remember what come after. So I put interrogation and it tells me here you can only hit enter. You cannot put additional things in this command. Okay, so if I hit enter, it will change the name of the switch. Those are the magic keys, as you can see, no? So we have those magic keys. Let me see. Oh, it's time. So we are going to do some lab with the switch on the router of Cisco system. So in the past, we didn't have virtualization. So the only way to do labs in the past, you will have to buy that. Like $400 one. And if you need to do a network, you need several of them. So it was very difficult in the past. Today, we have virtualization. So we are going to use GNS3. And in GNS3, we will have Cisco switch and Cisco router. And exactly as I'm doing here, we will do in the virtualization software. So all of us will be able to practice, even if we are not able to buy, and there is no reason to buy one if you want to practice, because we have virtualization software today, no? But of course, if you are going to walk in the area, you will have to manage a lot of these devices, no? JSU have a lot of these devices. For example, in this floor, there is a wiring closet here on this wing that connects all these devices to the switch that are there. So all these computers have an Ethernet connection. This Ethernet connection go in the ceiling and go down in the wiring closet and is connected to a switch. So you can imagine here we might have 30 computers. There are at least 30 cables that run from this room to the wiring closet. And much more, because we also have in the wall, if you see, we have some connectors for Ethernet. So we have more than just the computer that you see. We have much more because of the additional connector that we have there, no? Okay, so I will stop here. Remember, we have quiz in 1 week. So next Tuesday, we will have the quiz. I sent an email about it. Okay, I see you in 2 days, on Thursday.
Do you know what format the quiz will be in?
Yeah, it will be here.